I'll give you a joke. I can give you a joke. So a duck walks into a pharmacy, and he tells, oh, you can't hear me. Duck walks into a pharmacy, and he has chapped lips. So he says to the lady at the register, where's the chapstick? She points, goes down, picks it up, puts it on the counter. She said, how are you gonna pay for this? He said, put it on my bill. Come on. Come on, that wasn't that bad. You guys are tough. All right, what are we talking about today? Did he take it back or did I steal it? There it is. Wait, he said I'm not supposed to do anything yet. So you don't see this. Am I allowed to do it now? All right, guys. How do I want to describe it? First and foremost, for those of you who heard me talk for a while, I pick on the healthcare systems, but we all need healthcare, and we're in Pittsburgh, and we have excellent healthcare, okay? So I'm going to pick on GMOs, but it was a necessary technology, and the advancements that we've learned from genetically modified organisms have benefited us tremendously. Does everybody understand that? And I'll run through it all so everybody understands. So let's just say, from my vantage point, being in healthcare for 35 years and what I've watched, my conclusion is it's not the good old days. You know, the handshake was all we needed, and we all told the truth, and we all knew the rules, and no one cut corners, and no one did things just for money. Okay, so what I'm gonna run through is like a history of genetically modified processes. And believe it or not, they started in 12,000 BC, you know, which is pretty phenomenal. But that's what we're gonna talk about today. And at the very end, what I'm gonna do is talk about, I don't believe you should take anything that's genetically modified. And I'm gonna talk about, you make your choice, but make sure you know that they have to have it on the label. If you see GMO in the ingredient, then it's genetically modified, okay? Everybody understand? All right, so what is genetically modified? What does that mean? I got too many pockets, guys. Okay, what that means is that the organism has been modified at the gene level. Okay, everybody with me? Oh good, we have lots of paper. I can draw today. It's not an alien. What is that? It's a cell, okay? Does everybody understand me? This wall of the cell has two layers. That's going to be important. This is called cytoplasm. And this is called the nucleus. Okay, everybody with me? And we have billions of cells. The genetic modification, 12,000 BC, plants, okay? So if any of you guys are good with green thumbs and grow stuff, then you will know, we've all heard of Mendel, you know, with genetics. That was 1865. So what he did was he took peas, and what he showed was in a controlled environment, if you place the seeds together, then different characteristics would occur in the pea. Does everybody understand that concept? That's genetically modified because these are two plants, and if you leave them go by themselves, they're going to make blue peas. But when you put them together, over time, they're now going to have maybe yellow and blue or green. Does everybody understand the concept? So when we talk about 12,000 BC and plants, that's what I want you to understand. But technology-wise, what we're going to be focusing on is cytoplasm, nucleus. What's in the cytoplasm? What's called organelles. And let's just say, I'm going to draw it like this, that there's certain things, different ones that are important, such as the Golgi apparatus, or different, let's say, structures that enable the cell to function and divide. And then also whatever the cell's function is, they produce the energy necessary for that. Does everybody understand that concept? So I want everybody to understand the cell, the nucleus, the cytoplasm, and remember, way back it was the plants. Historically, 1974, a guy by the name of Herbert Boyer and Stanley Cohen genetically modified a mouse. Okay? And again, what's interesting about it is now we're not dealing with plants, now we're dealing with animals. And with this animal, what they found was there was a resistance in the mice to what's called ganamycin, which is an antibody, or antibiotic rather, excuse me. And what they found was that if they manipulated the gene, the nucleus, what they were able to do was create these mice that were resistant in such a way that they would not get the infection. Okay, so that was 1974. Why am I bringing that up? That's 50 years ago. So the technology we had 50 years ago to be able to get into a gene of a mouse and change the genetic material in such a way that they didn't even get the infection. So they were dying because they were unable, they had an allergy to the ganamycin, and they manipulated the gene in 1974. Does everybody follow me? I need you to understand all this stuff with me, guys, so you see why at the very end I'm going to make my case. Because I'm going to go through all the positive stuff first. But this is what happened in a way, and now I'll describe the way that you can understand it the best. I like it when all I had to do was scribble. I'd say this. Okay? What's mutagenics? Anybody ever heard of it? I just throw it out there, guys. It is the purpose to create a mutation in the gene. Does everybody follow me? Okay. So once again, we're actually getting into a cell with the purpose of creating a mutation. And how they do that is they take a cell out of the animal, and they go through a process. It's called a polymerase chain reaction. You may not know it as that, but I'll bet you've seen PCR. So if you're going for COVID and they stick it up your nose, and they say they think you're positive, but you say you feel fine, then they do a test, that's the PCR. Okay, so this is all you have to understand about a PCR, is you are purposely trying to change what you're working with. How do you do that? You have to get to the nuclear material, the DNA. How do you do that? What is this chain reaction? It's about that long, and there's 8 pouches, and you take a pipette and you put this genetic material in there, and then you put it in heat, high temperatures that change, 194 degrees, 138 degrees, 60 degrees, and by doing that, you disrupt the nuclear material, therefore you get the DNA. Does everybody understand that concept? So now you have the DNA. What do you do with it? You put it in a virus or a bacteria. Why? Because it grows. Bacteria grows, viruses grow. In a controlled environment, nothing wrong with that. And we've learned a lot about it. What does that mean? There's a lot of drugs on the market today that are curing cancer because of this technology. So I'm not opposed to the technology whatsoever, but you have to understand how this works. So we take the cell, we put it through this PCR test, and it's just a regular machine. What's it remind me of? Think of like an old television, about that wide, about that big. So they open it up and they put it in there, create these temperatures, and this disrupts the cell so that they can get the nuclear material. And so now they have that nuclear material, and we call it a genome, okay? There's a library in America of these mutagenic genomes. And why do I tell you that? Because we're going to get down the road here as we talk about it. You can get these materials in order to manipulate whatever you're trying to manipulate. Okay? Does everybody understand the concept? You have to understand the concept. So now you know that the actual study or specialty of mutagenics, you have to get the cell out of the animal, and then once you get the cell out of the animal, you get their nuclear material, and then you put that nuclear material into a organism, virus or bacteria, and they call it a bacteriophage. And what that bacteria, when it grows, it also grows that genetic material that you took out of the animal. Does everybody understand that concept? Because that's how we're going to get to cloning down here, but you have to understand this, because as I run through it over here, you have to know what the PCR is. That's what I'll refer to it as. So everybody understands the PCR? All right, take a break. I'm teasing. It's like, I don't want this to be a class, guys, but I want you to understand it well enough so that you see my concerns for GMO products. And again, they're labeled on the back. I'm going to repeat that 1,000,000 times. Please read labels. If you see GMO, I'm going to make the case that you should not take that into your system. All right? Is everybody with me? All right, so now we have over here, we'll put PCR, and they call it a vector, but that vector is either a virus or a bacteria. All right, how I got first involved with this is through wheat. Concept. The more you have, the more you control. America has a lot of wheat, okay? In 1896, wheat had 11 chromosomes. Is everybody with me? Chromosomes are genetic material that tells the cell what to do. 11. Today, 28. Okay? Is that good or bad? We've been eating it that was in the 80s when it all developed. So for 40-some years, we've been taking in genetically modified wheat, unless you're reading the label. Okay, so, and the reason I bring that up is why are they genetically manipulating it? So they don't lose any. How would you lose wheat? Crop dusting. Okay? Some of those chemicals would wipe out large areas of the wheat. So they went into the lab, just like, remember what I told you, what Boyer and Stanley did? You know, how they manipulated that mouse so the mouse didn't have the allergy to the gantomycin? Same concept. So this stuff that they were spraying and killing the wheat, the pesticide, they came up with this new, stronger wheat that was resistant to it. And in the process of testing it, killed over 30 million fish. Does everybody follow me? Like, this is what goes on, guys. Like, this is research. And through the research process, you have to know what's going on. So pay attention as I run through some of this stuff, because that's how I got interested. You know, the book, by the way, read it if you haven't heard about it. It's called Wheat Belly, B-E-L-L-Y. And it's written by a pediatrician. And also, I think it was two docs together. One was a cardiovascular guy. And the whole thing I just told you, it tells you that story about the fish dying. It tells you how they manipulated the wheat so that when the crop dusting occurred, they didn't wipe out their dollars, okay? So once I got into that and I started looking, what I found was amazing. Soy and corn. Probably also in the 80s. It's been manipulated. And then what I found was real interesting. They call it golden rice. I have to put salt here to finish the story. Okay? If you don't pay attention and you don't get out of the car to get your gasoline and read what's on the pump, corn is in most gasoline that we put in our cars today, okay? And in order to, let's say, modify it to that level, it's been genetically modified since the 80s. And once again, what happens is there's so many uses for it, so there's these large crops, and once again, to keep them alive, they manipulate it so they survive whatever disease process affects the corn. So it's also manipulated many times. But once again, the reason I bring them up, these are the two, actually number one, soy. Number two, the most manipulated genetically in the world. This is more in Asia than in America. We get more corn. So we're number one with the corn. And the reason I bring it up is because it is, they talk about how they want to feed the world. They talk about how they want to make things more healthy, like same as the analogy I use with healthcare. The reason managed care got in, the reason Obamacare got in, because they were going to insure more people and they were going to make healthcare cheaper. It's the line. The bottom line for us, though, is knowing what you're taking in. So again now, the corn and the soy since the 80s, and I put this golden rice, they've manipulated rice in Asia that's yellow. So, you know, the actual yellow rice, they call it golden rice. And the manipulation that's been done with it, Google it. Because what you'll find is it's a problem. But why I put it with the salt, different disease processes can occur from lack of vitamins and nutrients. That's why they put vitamin D in milk. Okay, so what happens is they were finding that a certain population was going blind, and what they felt was that they could put carotene into the rice to get rid of the blindness. So the purpose for why they changed it, top shelf. The problem, just like the loss of the fish, etc., what you end up with is changes that ultimately can lead to diseases. Because remember, mutagenics, you are trying to mutate that cell to be able to manipulate it. All right, is everybody with me? All right, 2007, 2015. Anybody ever heard of what was it called? Aqua light fish. That was in 2007. It was the first manipulation of a animal that they commercialized. And they took, everybody's seen lightning bugs, right? The thing that makes the lightning bug light up, they put into a fish, and they called it a glowfish. But that was the company that started. And what they did, that was the first commercialization, took off like it was alive. You could put it in your aquarium, you know, and imagine children that get the fish anyhow. Now you shut off the lights and you can still see the fish. So that was one of the commercializations. This one I didn't like. I'm spelling it wrong. Is that how you spell salmon? I like salmon. And the company that put this one out, this was, the salmon is manipulated for better flavor, like all these different things that when you read the article, you realize it's for profit. So it was another one of the commercial, and again, I didn't know. So if you guys already knew, you knew more than I did. I had no idea that in America we were eating, you know, fish that was genetically, you know, modified in order to obviously produce more, and then the taste, etc., that they were talking about. And that's why I bring those two up. That aquafish was the first commercialization. This was the second one that was big, that was talked about. All right, so now, hopefully you got a snapshot of, we'll put on here, history, the PCR, you want to remember how they do that, and the mutagenics. Okay? And now we'll put new. Stem cell. So in the lab, we can do these things. It's supposed to be for research, but in the process with the mutagenics, we are taking disease and we're manipulating disease, okay? And terminology such as gain of function, you know, what does that mean? That means that you're manipulating the gene of whatever you're dealing with to gain another function, to be able to have it so that it's doing something that nothing else does. Transgenics. I don't want to say it wrong, so I'm not going to even talk about anything related politically. But look at this word. We are genetically changing humans through animal experimentation. And so what happens is the science, the technology, it's there. It's all there. And what's happening with it, it depends on the money. And it depends on where you go. For those of you that are my patients, you know Holly, my nurse practitioner from China. When she last went, her grandfather passed and she went over, and when she came back, she told me that the, what's the word they call them? I'll figure out the word. But they are, she said, you think all Asians look alike. And she said, so you would not be able to tell the difference between a humanoid, that's what they call them, the humanoid and a real person. And I said, sure I would. And she showed me the articles, and it's phenomenal. Like literally, through stem cells, we can make everything. And so you can make skin, you can make hair, you can make, I mean, it's just phenomenal. And then she talked about the technology that they have. They didn't do it with her grandfather, but you can keep the brain alive and interact with the brain. So that, you have an aquarium of fish, now you have a spot and you can ask questions of people that have passed on by preserving the brain. And so this is all being done. And the only reason I bring it up, that's why I said I didn't know how to approach it. I don't want to send anybody's mind anywhere other than genetically modified organisms and reading the labels. But I have to go through all this stuff so that you guys see what I see as I read through and try to figure out where we're going, how we're getting there, what's the best, what's the worst. And do we say to patients, don't worry about it, genetically modified is fine. And as I've researched everything, I'm not telling you that. I'm telling you that read the label and make sure that you want that well enough that you're going to go ahead and take whatever kind of risk there may be. Because all the researchers will tell you everything's healthy. They'll tell you that there's no problem with it. The FDA will tell you there's no problem with it. But what I see, there's a big change. Okay, so with the transgenic, we're getting let's just say that if you can change we'll call it organism to provide a function it was not able to provide before. So it's new for that animal. That's how I would classify transgenics. Good, bad, or indifferent. That's up to the individual. From my vantage point, I look at it. Maybe go back to '74 with Hoyer and Cohen. And when they were able to change that mouse, to make that mouse not have any sensitivity or allergy to the kanamycin. I thought that's awesome. All the things you could do in medicine, fabulous. But as you see what's happened with it, when profit gets involved, then things can change. And so what I see now is the genetic modification is to make more. So you can modify it so that you get, for the same unit spent to produce that same one unit that used to produce one, that now one unit can produce up to 100. And that 100 now is more profit. But is there a benefit to us? I mean, is it really food that's so healthy it can feed the world and it's going to be wonderful and we should do this forever? I couldn't find that answer to be yes. So that's why I feel it's something that we have to pay attention to. So what do? All labels, everything, food, water, beverages of any kind, medicines. The label has ingredients. Listed from most to least. And what I want you looking for, 3 things. 1, fructose corn syrup. Stay away from it. There's too much proof. It's not worth wasting the time anymore. There's not any aspect of it that is good for you. So if you see it on the label, don't take it in. The second one is they have to put on the coloring. You follow me? It'll say red dye, blue dye, whatever. I think the talk a couple months ago when I talked about products in America that aren't allowed in other countries, Fruit Loops. And I thought, why Fruit Loops? And that's why. Those dyes have actual, let's just say, mutagenic potential. That's how I'll say it. Okay? And Google it, because it's all in there. You can look up any of it. But again, the dyes are big. And then the third, GMO. So if it's been genetically modified, remember the PCR heats it up, that gets the gene. Now once you have that gene that's been extracted from someplace else, you're placing it in a bacteria or a virus to divide. That's what they do. That's the process. So make sure you're aware of all that as you're looking at the label. And everything that we eat, you can get without fructose corn syrup and without genetically modified. And I always thought it was going to be very, very expensive. It's not. You know, places like Aldi's has a lot of it. Some of the stores, what's the name of it? I think Delilah's is the one that's out of Jeanette, Pennsylvania. Like there's different things you can get online, but it's all available, like everything from vegetables that are organic all the way through to anything that you're eating right now. It can be gotten without anything in it. All it takes is a little research, and it's not difficult. But the point that I want to make is if you read that label and you see one of those there, what potentially can happen? What an artist I am. Look at that. That's pretty good. All right, so this is where you swallow. This is the esophagus. Then we'll put the stomach like this. Okay? And then we'll put small intestine. And then we're going to pretend we're going to turn them sideways this way. And we're going to see the colon. And behind the colon, I'll put a B for bladder. Okay? Genetically modified organisms have created an increase in bladder cancer and colon cancer. Okay? All Google it. You can see it. It's all available to find. And what I just put together is the GI tract. We swallow. In your mouth, there are glands. How many times are we supposed to chew our food? 32 times. And then all those glands secrete what they need to secrete to start breaking down the food. The esophagus, just a tube. Stomach. Stomach produces acid to break down the food more. Then it makes its way, if we're doing sideways, the stomach looks like this. And then you have the C-shaped duodenum. Then we'll draw the pancreas in here, and we'll draw the gallbladder in there as well. So when the food makes its way around the duodenum, all the secretions come so that the food can be ingested by the small intestine. From here to George is about how long our small intestines are, but they're all folded up like a fan. And then you come to the colon. So the appendix sits here. That's where the small intestine gets to the large intestine. This is on the right side. This is the ascending, transverse, descending, sigmoid to the anus. So that is the GI tract. And genetically modified substances have had an impact. They see an increase in the statistics and the data that they look at. So that's the part that I get frustrated with. I mean, it's great. Everybody tells you get your colon checked, and all the different people are looking to find the colon cancer, but the prevention still comes from what we're putting in. So please pay attention. Please read that. Okay, the other one that I wanted to go through. Medications. Technology and AI. I had my first experience with AI yesterday. Okay, I am terrible. Here's my speed. Flip-top phone. I'm terrible with the computer. So I go in yesterday to a place I work, and they say, Dr. Coppola, you have to learn how to do the computerization now in AI. And I said, what's that? Oh, you're going to love this. Okay. So you go in, I got 5 new passwords. It's crazy. You know, and you have to find your way in. It takes probably 5 minutes for the thing to spin. And essentially what it does is all the information gathered on computer, on your patient, is in there. And so you hit a button and poof, it's there. And then they call it cut and paste. You guys probably know that. It's all new to me. You got to hold the mouse and move this all the way down. And then you have to hit C for copy. And then you put it where you want to put it. You hit a button, poof. It's unbelievable. But it reminds me of the first patient I saw for a follow-up when computers came. And it was a female urologist. This particular patient had cerebral palsy, and he had a suprapubic catheter. And so he was going in to have the suprapubic catheter replaced. Like, they put the wire in, take it out, put a new one in so you don't get an infection. So the girls handed me my chart, and there was 12 pages. And I'm reading, going, wow, man, this is amazing. This computer, it's amazing. Like, I'm reading it thinking, I guess I got to do it. This is pretty phenomenal. So I went, the patient's name was Frank. Hey, Frankie, how you doing? Hey, doc, pretty good. I said, so I saw you had the catheter, and I got the note from Dr. So-and-so. Who? I said, Dr. So-and-so. I never saw a doctor. I said, you see anybody? Yeah, somebody who was a physician assistant, I think. He was in for a minute. And then the nurse took my vitals, and then the nurse took me back out. And that's when it hit me that, wow, it looks wonderful, but you're not interacting with the patient. So I asked if I had to do it. And they all frowned when they said it. No, Dr. Coppola, you don't have to do it. But I was amazed at, I had the cell phone for the weekend, I was on call. It finishes your sentences. You guys have that? Like, that's AI. So the amount of information, here's how it was explained to me, and this was by a nuclear physicist. Our brains are 95% water. And we've done the, look at the G with your right finger, bring it in front of your right eye. The time it takes for your body to focus, it's called Edinger-Westphal's nucleus, is 350 milliseconds. Okay, so that's how fast the brain can work because of the fluid medium, all right? So recognizing all of that, and the most brilliant person that we've always equated to the most brilliant person is Einstein. And they somehow scientifically proved he used 9% of his brain. So the bottom line is we don't even know what the potential is, but it's there. And the speed at which everything can be done is there. So now with the technology and the communication capabilities that computers are able to do, they're using what we don't use. And so they're finishing your thoughts. They're definitely a step ahead of you. Is it a good thing or bad thing? Excuse me, I say it's just like what I talked about when we started. Healthcare has changed drastically, and I watched it. I complain about it all the time, but it's still tops in the world, and we're lucky in Pittsburgh because we have tops in the world. And that's how I feel about some of the stuff we just talked about. But when we get into medications, technology, and AI, you're going to hear a lot of different things. And I think that your best approach is to talk to your physician about your health. Like, one of the things they'll say soon, I think it's all coming out by January, they'll have the ability to tell you what diseases you have and is your medication right for you. Like, is that the medication you should be taking? And it'll be done in such a way that you'll be able to go into the pharmacy, maybe wave your hand over something, or they scan you somehow, and they'll give you that information. Now, right, wrong, or indifferent, I don't know. I just know what I read. But that's why I wanted to make sure everybody understood the PCR, everybody understood the things we talked about first, because as we get into medications, the new technology, and AI, what you want to be is cognizant of your routines, what you do, your sleep, when you're awake, your exercise, what you're eating, what you're drinking. All those things, they're out there somewhere. Like I said, these are my patients that I played on the computer yesterday that was AI. There was stuff in there I never knew. And when I brought it up with the patients, they were like, oh, that happened when I was younger. I forgot all about that. But the whole point is that there's a change that's going to come that we're not, it was the first time I saw it yesterday. And when I hit this on patients that I thought I knew, and the information that came up on that screen, like the whole thing took about 5 minutes, but it was childhood illnesses, what you eat, what you drink, how many hours you sleep. It's called a matrix. And I think we've talked about it. If your doctor has a computer when you're seeing he or she, then they're in that matrix. I'm still not owned. I hope I'm never owned. But right now, I don't even have a computer in the office. I still write things down. But I think where the technology is going to go to, so be cognizant of it. And that's why I'm saying now, watch what's in everything you're taking in, and then please make sure that you think through, because you're going to be asked, what's your daily routine? What time do you get up? What time do you go to bed? All those kinds of things. And don't just say it, do it. Drink water. Water's still the best thing to do. Okay, is everybody with me? So let me give you an example. Does everybody know what a pilot study is? All right, I did one in 1983. It was part of the DRGs, Diagnostic Related Guidelines. And I remember talking about it. I don't know if we were here. No, I think I was over, it was, what's the place called that was on Bellevue Road in the North Hills? Eastern Star. It was the Eastern Heart. That's why I used to lecture. Okay, but long story short, I said that. Like, this was June 30th, 1983, I admitted a patient with pneumonia. So you go down to the emergency room, you examine the patient, you look at the chest x-ray, and you look at the sputum that they cough up. You make the diagnosis, you write your orders, you go back to bed. July 1st, because we were on every night as it came through the weekend. July 1st, I got called, I went down, did the same thing, went up, laid down, and I got a call. Dr. Coppola, you have to come down and do a gram stain. Anybody ever heard of a gram stain? You heard of gram-positive and gram-negative bacteria? Well, the way you determine that is a bunch of dye, okay? So you take the sputum, you put it on a slide, and then you put these dyes on it. And so you end up with blue, red hands. I mean, it's ridiculous. It's like, So I said, it was a nurse that said that to me. So I said, bleepity, bleepity, bleep, and I hung up the phone. And then I got called by the program director, who tells me if I'm not down in the emergency room in 5 minutes, pack my bags because I'm getting thrown out. So I go down and I do the gram stain. And it showed it was a gram-positive bacteria. I ordered the same medication, but the whole point was you have a diagnosis in the emergency room. Prior to that study getting through as the pilot for the DRG, average length of stay for pneumonia in 1980 to 82, 5 days. It went to 2 days, okay? So being part of a pilot just means that something's being tested. Does everybody follow me? All right, so pilot program right now. This is in Tallahassee. I can't spell it, so I'm scribbling, okay? And what they have done is they've taken a sample. I think they have 1,000. And a senior they're defining as over 55 years old. And with this senior group, they're paying attention to what they're eating, what they're drinking, their exercise, their sleep, and then depression. Depression was real big on there. And in the process, they are making a determination of medication that might improve. Again, we'll call them the ADLs. Memory is big. Activity, sleep, and I'm putting a big D for depression. Okay, there's medications. Anybody ever heard of serotonin? It's called serotonin reuptake inhibitor. It's a chemical in the brain that has an effect, and then the body's very, very efficient. Takes it back up to be used again. So there's a lot of antidepressants that are called serotonin reuptake inhibitors. So it stops that from happening because that's the happy hormone. If you keep the serotonin around, then it enables you to be happier. Okay? So what we have found is memory, sleep, and depression through some of the, what do they call them? There's a term they use for the AI. Memory, depression, sleep, function changes, increased fatigue, increased illnesses such as upper respiratory infections, urinary tract infections, and cellulitis. In the data that I read, it all comes down to the dollars spent in your last years of life. They can go back to this data and information, and they want to manipulate memory, depression, and sleep. And when I say manipulate, I'm all for improving somebody's sleep because we all know if we sleep better, we feel better, we do more. I'm all for helping with the memory. And definitely, if you're depressed, I think that there definitely needs to be something that you do to help yourself out of that melancholic situation, okay? I want to have that remembered, all right? So I'm going to put it back on the other side. Last year, data gets reviewed. Two studies over 100,000 patients. So we'll say 500,000, 250,000. And it shows depression, big. It shows that UTIs, big. And it shows stroke or TIAs, big. And again, remember, I just want you to look at this again because I don't want to keep pushing it out, but I want you to remember how these have become memory, depression, and sleep. When I call them hot items, it's what Medicare is looking at because they're spending a lot of money, okay? Dementia, memory, depression. You know, when you're depressed, you're not as functional as, you know, you could be, let's put it that way. And I think that what I've seen with patients that don't sleep, it's interesting. I worked 11 to 7 when I went to college. And to me, it was the best of both worlds because you were able to study, Yeah, I was fortunate. I worked in I was at Hammond Medical Center in the operating room, so unless we had a trauma case, I studied. So I was lucky. There were a lot of people that didn't have that luck, but there were a lot of people that worked 11 to 7. And what I find, my patients that worked 11 to 7, they can't sleep regularly at night even after they retire 10 years out. And so there's reasons of behavior that change your sleeping habits. But it's all being pushed together. And so once again, what I want you to pay attention to is the UTIs, big dollars spent, stroke, TIAs, but they are nothing compared to weight loss. Everybody hears the commercials, Ozempic, all the different ones that are out there. Once again, I'm not telling you not to, but I'm telling you to make sure that you understand what you're putting in your system. Because I have so many patients that like they come back with somebody telling them that because their BMI is over 35, even though they're not diabetic, they can take it. And it's all for the weight loss, okay? Again, guys, genetically modified, that's why I threw up the medicines. All right, everybody pay attention because you're gonna get advice based on a diagnosis and the treatment based on what AI says. Let me give you an example. I'm independent. I'm on staff. I still go up to Swickley, but long story short, one of my associates joined the Swickley, what do they call it? ACO, Accountable Care Organization. You have to follow their guidelines. One of the things that I fight with him about is it's called procalcitonin. If you have become part of an ACO, you follow their guidelines. If the procalcitonin is normal or low, the patient does not get an antibiotic. Is everybody with me? So I had a patient that, just like I talked about the pneumonia, if someone's coughing up stuff and it's not clear and they have a fever and chills, you don't wait till the sputum comes back, you start the antibiotic on the patient to get them well beforehand. So that's the way I was taught. Once again, that costs money. And so the procalcitonin has to be elevated in order for the patient to get the antibiotic. So everybody follow what I'm telling you. All these protocols are coming out. I don't know if it's going to change. Stay tuned. We'll see what happens with the healthcare. But the fact that the medications and the technology and the AI, they're going to come up with, again, I don't know how they'll call it for us. Won't be a policy because that's too restrictive. It'll probably be recommendation. That's how it'll probably come out. That they'll recommend that this is what you do. All I think you need to pay attention to is make sure you know everything that they're asking you to do. And talk to your doctor, because your doctor will know. Even if they're owned, we all understand medicine. We understand what's going on. So please pay attention to that. Okay, so what I want to make sure of, guys, sorry, I hope it didn't feel like a classroom because that wasn't the intent. But I wanted to make sure everybody still understands what the PCR is. I want to make sure you understand what mutagenics is. And I want to make sure that you understand what genic is, because it's all happening now. And as this goes on, let's use 200 to 2030. I've heard that thrown out before. You know, the AI is going to have a hand in everything, but specifically meds. And are you tolerating them? And then make sure if someone wants to get you in a study or they want to ask you questions, I'm not telling you not to, but I remember the last wave of this. The last wave of this was probably like 2012. I actually had patients have surgery and I didn't even know about it. They would get a call from their insurance company. The insurance company would send someone out to the house. They would get like a $25 gift card or something. And then like the patient would tell them they had back pain and they would end up undergoing a procedure on their back without, I didn't even know. And what was unfortunate was since I met the guy, he had back pain. You know, so he had the surgery, felt better for about a week or two, and then he was back to the pain. So the whole point is know who you're talking to, make sure they identify themselves. So, you know, if they say that they're with your insurance, ask them to tell you what your address is or what your, you know, number is on your Medicare. You know, have them give you proof. And again, guys, I don't want to have anybody, you don't have to worry actually. Here, no one's coming in. You know, no one's going to bother you guys. I'm just throwing it out there to pass the word. Because like I told you, when I did the wheat, that's what made me look up the genetically modified stuff. And then when I looked into all of it and realized like medications are big. Once again, needed. If we wouldn't have figured out, I was down in Baltimore with the first AIDS case. I was down at Hopkins. That was in 1981. You know, I saw what the electron microscope did to identify the virus and how everybody worked so hard to figure out a way to stop the virus from growing. You know, so everything is positive. I don't want anybody to take any negative from this, but I just want everybody to make sure they understand, you know, since the 80s, so many things are genetically modified. And please make sure you read the label. And if that label has any kind of dyes, stay away from it. If that label has fructose corn syrup, stay away from it. And if the label has anything GMO, they have to put GMO. If you don't see those three, I think it's safe. You know, you guys choose. But once again, guys, I'll leave you with one more thing. Okay, I like genetics. You know, we all had to take genetics when we were in medical school. And I think that understanding it is simpler than you think. Recognizing what has been modified is so important for you in terms of knowing what you're putting in your system, guys. I have to make sure that is the biggest thing. The cell manipulation that's going on, it's for good, I have to say. I mean, the mutagenics and everything, the reason it was started, definitely it was all good. It's killing disease, it's helping out cancer cures, all those things are positive. I don't want to say anything negative about it, but putting it in your food or your drink, remember, even beverages, fructose corn syrups and beer. So please pay attention to it. And then the last one is, please pay attention. If you guys, like I said, I'm a flip-top phone. I do use the cell phone when I'm on call, 5G or whatever it's called. Please pay attention. Data is important. I mean, it's so important. Don't give out any information to someone unless you know who they are. I mean, I always heard those commercials where, like, you know, they can steal your identity. It happened to my daughter in Florida. She's a veterinarian. And it's just, like, you never think it'll happen to anybody. It can happen. So that's what I leave you with. A lot of stuff, guys. Sorry to throw so much at you, but it was so striking to me when I read about what I was reading about that I just had to pass it along to make sure you guys have nothing to worry about here. And yet, you know a lot of people. Pass the word, please read labels. Good. Sorry I was late. Any questions, guys? Yes?
On the cans, they say so much sugar, then added sugar. They don't tell you what it is.
True. Stay away from it. Yeah, if they don't put everything in. Now, did you see the ingredients, though? Did you read the ingredients label? And it says sugar, and then when you go to how much, it just says none added. It doesn't say how many grams. It should tell you above where it says ingredients, they should have a listing of protein, sugar, things like that in there. And it doesn't tell you how many grams of sugar are in there. Doesn't list that?
Yeah, well, it does sometimes, but it doesn't say, it just says added sugar.
Just added sugar. I'd stay away from it. If they're not putting it in it, I'd be afraid of it. It's good. Any other questions, guys? Thanks for having me.